In this video, we're going to evaluate the integral of 1 over 1 minus cosine of x. Now, as given, a U substitution is not going to work here. Other techniques you can use, multiplying by a conjugate, especially when you have a radical involved. Similar process here, multiplying by what would be the conjugate of 1 minus cosine of x is 1 plus cosine of x. Multiplying the numerator and denominator by 1 plus cosine of x. And all we're doing here is multiplying the integrand by 1, because 1 plus cosine of x over 1 plus cosine of x is 1. So we haven't changed the integral. It may look different after we multiply, but it's like multiplying any number by 1. Doesn't change it. So in the next step then, in the numerator I'll have 1 plus cosine of x. In the denominator, it's just like multiplying a minus b and a plus b. The difference in the sum of the same two terms just gives you the difference of the squares. This would be 1 squared is 1 minus cosine squared is cosine squared. One of our basic fundamental identities tells us that the cosine squared of an angle plus the sine squared of the same angle is equal to 1. Cosine squared plus sine squared of the same angle is equal to 1. So from that identity, this has to equal to sine squared. So this would be sine squared of x. As if I equate these, I can write that as sine squared plus cosine squared is equal to 1. On top, it's still the same, 1 plus cosine of x dx. And then I just divide the terms in the numerator by sine squared. So this would be 1 over sine squared. 1 over sine squared of x. We know that sine and cosecant are reciprocals. So 1 over sine squared of x is the same thing as cosecant squared of x. And the next one then would be plus cosine of x over sine squared of x. I could use the substitution here, or I could just rewrite this. Let's see. Do this first. We can integrate the first one as is here. The integral of cosecant of x is minus cotangent of x. Go back the other way, take the derivative of cotangent. It's minus cosecant squared, but then you have the negative. So that checks out, cosecant squared. Now for this one here, I can break up the sine squared into sine of x times sine of x. And the cosine x over sine of x, that's cotangent of x. And then I can put a factor of 1 there. I can always multiply anything by 1. So this would be 1 over sine of x. That's cosecant. Let me put it in the front. So cosine of x over sine of x, that's cotangent. And then a factor of 1 here over sine of x. 1 over sine of x is cosecant of x. What has a derivative? What trig function has a derivative of cosecant of x, cotangent of x? Well, it's minus cosecant of x. And I can actually say the derivative of cosecant of x is minus cosecant cotangent of x. That's why I have the extra negative here, because the answer here is positive. And then I have the constant of integration. Now another way you could have done this, and just for the heck of it, let's just go ahead and do it. I could do it with a U substitution. So let's suppose you had this integral by itself. Let U equal to sine of x. So this is really the video, but I'm just going to add a little extra in case you're interested. I let you look at this integral here, integral of cosine of x over sine squared of x. Let U equal to sine of x. Then du would be minus cosine of x. dx. So it's clear. I'm looking at this here, this integral here. So this one is a regular substitution for this one here, because if I take the derivative of sine, that's going to give me a cosine, minus cosine from here. So let's multiply here by a negative here. So cosine of x, right here, cosine of x dx can be replaced by minus du. So we write the integral this way. Say it's the integral of minus, I put the minus outside, minus cosine of x dx, that's your du. And then the sine is the u. So this would be sine squared, or this would be u squared. And it's minus the integral of, that goes upstairs. This will be u to the negative 2 du. Now it's a very basic monomial here in terms of u. So add 1 to that power. That's a negative 1. Divide the coefficient by a negative 1. Gives me a positive. And I get the constant of integration. And remember, u is sine of x. So this is the same thing as sine of x. Base the u by the original expression, sine of x. It is to the minus 1. And then you have a minus out here, remember. So minus here. But sine of x to the negative 1, that's the same thing as 1 over sine. Sine of x to the negative 1, it's the same thing as 1 over sine. But because the sine and the cosecant are reciprocals, 1 over sine can be replaced by cosecant. And then, of course, I have the minus over here. So we still get the same answer. Minus cotangent of x, minus cosecant of x, plus the constant of integration. So here I'm just pointing out that sometimes you have a problem and there's more than one way to solve it. One way, of course, obviously, was the last one here for this part of the integral here, because I have two integrals actually here, if you want to think of it that way. The first way, again, I broke up the sine, and I got cosecant over sine was cosecant, and 1 over sine, cosine over sine was cotangent, rather, and 1 over sine was cosecant. And we got the integral to be minus cosecant of x, which is the same thing we got using the u substitution. So either way, the answer is a negative cotangent of x minus cosecant of x plus the constant of integration. Thanks for watching. We'll see you next time.